Okay, so again, on rolldiceonline.com, make sure one dice rolled, number of rolls 10, roll the dice, and then record them in your table that I provided you on your notes. And then I'm going to go around to each of you and figure out how many 4s you ended up rolling. Let's put my results in for you. Bless you. Everyone got some results. Okay, now what I would like you to do, what's your experimental probability of rolling a 4? Mine, I rolled 4 of them, so mine would be 4 out of 10, reduced 2/5. So find your experimental probability right now. All right, find your experimental probability. Look around at the people next to you. Did you get the same thing or different results? How many of you got different ones? Okay. Anybody get 1/6? How many of you got 1/6? Oh, shocking, huh? All right, none of us got the theoretical probability. Again, why is that? Because this probability is based off of what? Your experiment that you just did. Okay. Now what I want to do to make this even more lifelike is we're going to make a dot plot. If you guys want to see what we're going to end up making, I just Googled a couple real quick. These are all dot plots. This is what we're going to end up making as a class right now. How many 4s did you come up with? All right, and I'm going to go around to each of you right now. We're going to plot it on a dot plot. So what I need you guys to do, make an X and a Y axis. The Y-axis is frequency. X-axis is the number of 4s you had, number of 4s. I had 4 4s. Did anybody have higher than 4 4s? So I know what to label the X-axis as. Anybody have higher than 4 4s? Okay, so we'll just label the number of 4s. 1, 2, 3, 4. Since nobody had more than 4 4s. Anybody have no 4s? Real? Okay. Guess we got to put a 0 on there. First time that's happened. Hopefully one doesn't go above 11, but we'll see. Okay, ready to go? I'm going to go around the room. I had 4 4s, so I'm going to put a dot right at 4, which tells me one person had 4 4s. That's what that dot represents. Ethan, let's start with you and let's go around the room. How many 4s you have? Okay, 1. Let's move up, ladies. 1, 2. Lucas, 4. Cooper, 4. What'd you have? 2. 1. Maddie. Patrick. 4. Annika. 2. You guys had 0s? 2 0s? Right up there. There's a pass right there. Greg. 3. Emily. 1. 1. Anna. 1. Brianne. 2. Okay. So what's our class probability now? Well, everyone rolled how many times? 10, right? And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 people, including myself, did it, and we each rolled 10 times. So how many total rolls did we do here? What? 18 people. I'm included in here. So it should be how many? 100 and all together, we all rolled 180 times. That's 10 times 18, right? Everyone agree on that part? Okay, how many 4s came up? Let's count them. Well, this represents 4 every time. So how many 4s were here? 4, 8, 12. So there's 16 4s that came up here. How many here? What? 3 4s, yep. How many here? 8. How many here? 6, 7, and then obviously 0 here. So how many 4s came up out of the 180? Want to add them up with me? 19 and 15, 34 4s total out of 180. What's that? Anybody? You guys got your calculators out now? What's it reduced down to? As a fraction? 17 over 90, which is what, Cooper, as a percent? 19%, right? What's the theoretical probability? 1 out of 6, right? What's 1 out of 6 as a percent? Go ahead. What's 1 out of 6 as a percent? It's like 16.6 repeating, right? Is our class one closer than yours was? Figure out what your experimental probability was. Mine was 2 out of 5, which is 40%. Is our class one closer than yours? I'm going to guess everyone's going to say yes. All right. Why is that? That our class one is closer to the theoretical than your trial by yourself? Ethan? We're doing more and more and more. And you guys agree that the more trials we do, what's going to happen? If I said, hey, everyone, now go roll your die 20 times, our class probability will be what? Closer and closer to the theoretical one. Right? The more trials we do, the closer it becomes. Watch and learn. This is my final go here. All right? Now, is it really realistic of me to say, hey, guys, can you roll your die 300 times? Probably not. We don't have the time for that. That's unrealistic. So what we do instead is we create what's called a simulation of the event. So underneath, I need you to get this table down for me. The number on the die that comes up, 1 through 6, and the number of times it comes up. I'm going to do a simulation for you. Because we don't have the class time right now for you guys to roll 300 times. How many times did we roll in our class one example again? 200? No, it wasn't 200. 180 times, right? Let's up it a little bit. I'm going to up it a little bit. I'm going to go 1,000. Okay? I'm going to roll 1,000 and let's see what happens. I'll read you off the results and you just write them down for me. Ready? The number 1 occurred 175 times. The number 2 occurred, I'm going to go 165 times. The number 3 occurred 140. The number 4 occurred 180. The number 5 occurred. What did I have you guys use for 1? It's 170 then for number 5. The number 5 occurred 170 times, and number 6 occurred 170 times. I got to eyeball that. Okay. Read me off it again. 175. What was 2? 165. Ethan, how about 3? 144. 180. 170 and 170 again. Okay. Again, these may not up to 1,000 because I was trying to eyeball it there. All right, now let's go to number 4 again. 4 occurred how many times? 180 out of 1,000. You guys want to tell me what that is as a percent? 180 out of 1,000? Ends up being 18%. This worked a lot better third period, the numbers, but okay. Closer and closer we get. It was 19% when we just did our 180 trials. Now we just went to 1,000, got a little closer to that theoretical probability. Okay? What I'm trying to show you is, guys, the more and more trials you do, the experimental will get closer and closer to the theoretical. All right? So there's the conclusion right there. The more trials we do, the more trials done, the closer the experimental probability gets to the theoretical. And how do you think this is going to start looking? The more trials I do, how do you think the bars are going to look? More even. Because remember, what's the probability you get a 1? Still, these are all 1 out of 6, right? Here you go. Here's 10,000 now. Closer and closer they all get to being level. All right? Questions from you guys? Do we see that now? Your 10 tries, probably not good enough. I need to do more and more and more to get to that theoretical probability. All right? Okay, be ready to speak here, unfortunately. Let's go to the movies. Okay, more experimental probability. They surveyed age groups for coming out of the theater. How old are you? And they wrote down their results. What's the probability we get a customer that's between 12 and 46? Okay, between 12 and 46. Again, experimental probability, a survey was just done. Go ahead and circle the numbers that I would count as between 12 and 46 right now. Circle the frequency that I would count between 12 and 46. Here we go, Catherine, what'd you circle? 13 here. That's between 0 and, that's ages 0 to 7. What are we trying to find? Ages 12 to 46, so which one should I circle first? Okay, what else should I circle? Yep, any more? Yep, and? Okay, go ahead. Your calculator, whatever you got to do, add them up for me. Tell me how many there are there. 157. Brandon, how do I find what the denominator is going to be here? That's my total, right? Hey, how many total people took this survey? 157 plus the remaining ones, which would be 254. And I can tell you that doesn't reduce, so we'll keep it as that. Questions on how we found both there? All right. Jim took some cards out of a deck, put them back in, recorded all the different suits. What's the experimental probability of drawing a heart here? Based on the cards, experimental, not theoretical, experimental. So, Vinny, how many hearts did he draw out? He drew 5 hearts out. Out of how many there, Anna? Total cards. Out of 25. All right, so it was 1/5 his experimental probability of drawing a heart, 1/5. All right, let's everyone stop right now for me. Stop, don't answer any questions. I have been teaching this class for the last 10 years, and it seems every single year, more and more kids have no idea what's in a deck of cards. Okay, so let's just go over what's in a deck of cards right now. I'm not trying to joke or anything. I'm serious when I say they don't know what's in a deck of cards. How many total cards are there? Anybody know? There's 52 cards. It's broken up into 2 colors, red and black. How many of each? It's broken up equally. 52 cards separated evenly. 26 and 26. Okay. Red cards are broken up into 2 suits. They are hearts and diamonds, and they're broken up evenly between the 26. So how many hearts? 13 hearts and 13 diamonds. Okay. Black cards are broken up into 2 suits. What are they? Clubs and spades, and they're broken up evenly. So 13, and I apologize already. Clubs, trees, broccoli sprouts, whatever, and 13 spades. There you go. It works. Each suit has what cards in them? Ace, king, queen, jack, and the numbers 10 through 2. And don't be the kid that's like, what about the Joker? Nobody cares. Nobody cares. Okay, nobody cares. All right, so there's what a deck of cards is. Does anybody use cards anymore? Go fish. Okay. I was trying to keep it a little low key or a little bit. All right. True. War. No, nobody for war. Like if you throw a 5 and I throw a 6, I keep the 2 cards to myself. Try to get the other person out of cards. No. Wow. Okay. Or do we just stay balled up in the corner of our room? Right, Lucas? All right. Do you play cards at all? What games? Oh, excuse me? Oh, okay. All right. All right. So here's what this guy did. He did a second test now. He did it again. He did a second experiment. Here's what I need you guys to do. Combine both his experiments right now. Okay? We're going to do probabilities based on both of his experiments combined. Oh, we should actually answer the questions first, huh? Sorry. Part B. Find the experimental probability of drawing a black card. This is why I did it. A black card consists of clubs and spades. So how many total clubs and spades did he pick here, Brooke? Clubs and spades. 26. Good. I'm just going to put P, probability of BL. Guess what the BL stands for? Well, you guys are good. Black. Yep. How many, Brooke? Sorry. No, hold on. That was my fault. We're still on the first experiment. So clubs and spades from the first experiment. 7 clubs, 9 spades. You okay? What is it? 16, yeah. What did you say? Oh, I thought you said 26 before. Okay. All right. At a 25. Now let's combine the results. Theoretical, though, first. Theoretical probability of drawing a black card. Theoretical, meaning go to an actual deck of cards. Theoretical. Isabella, how many black cards are in a regular deck? Out of 52. 26 out of 52, so half of that. That's a half. That you draw the black card. Okay, combine results now. Combine them now. What's the experimental probability you draw a heart? Combine your results now. So out of the 2 experiments, Patrick, how many hearts did he end up picking? 11 out of 52. Yep. And I don't think that reduces. Theoretical probability you get a heart. Megan, out of a deck of cards, how many hearts? How many? That's 4 suits. How many hearts are in each suit? 13, yep. Out of 52, so you have 1 out of 4 shot. Which is what percent, by the way? 25% chance, right? That's a 25% chance. What was the 11 out of 52 as a percent? 11 out of 52. Matt, what do you got? About 21%. And then go back up to his first just 1 experiment when he found it was 1 out of 5. What's that? What's that percent? That's 20%. So here's what I want you to explain to me. After he did 1, it was 20. After he did 2, it was 21%, and the theoretical was 25. Why did it get closer? After his first experiment, it was 20%. Second experiment was 21%. So after his second, it got closer. Why? Because he did more trials. Yes, explain the results. Jim performed more trials. Are we seeing that? The more trials you do, the closer it'll get to the theoretical probability. Anything you want to ask? Last thing I want to ask, and hold on, before I do that, I got to stop the video. Because whoever's watching this won't care what I have to say now.